These problems are about prime numbers. And remember, prime numbers are those numbers that only have 1 and themselves as factors. So prime numbers, only 1 and itself as factors. And remember, factors are those things that you can multiply together to make the number. When we're looking for prime numbers, there are a couple of tricks that can make it easier. This first problem says which number in the given group is a prime number. So we've got these 4 to look at, and we've got to figure out which one is prime. I would encourage you just to eliminate the ones that you know aren't prime. And most even numbers, all even numbers really except for 2, are not prime, because 2 will be one of their factors. You can divide 42 or 44 by 2, so 2 is a factor of both of those. So I'm going to just get rid of the even numbers there. That's already cut it in half. If I look at 45 here, I know that's divisible by 5, and any number that ends in a 5 is going to be divisible by 5. So I can get rid of that one too, and already I've narrowed it down to 41. And presumably the people who wrote this question wouldn't give me a choice that didn't have a prime number, because that's what I'm looking for. So I could just assume that 41 is prime, and that would be the right answer. If I wanted to test it, just to make sure, I might get out my calculator and try a few divisibility tests. I would take 41 and divide it by, well, I know it's not divisible by 2 because it's odd. Let's try 3, and if I get a decimal, I know that doesn't work. 3 is not a factor. If I get a whole number, I found a factor. Let's try this again. We'll divide it by 4. Nope. We can divide it by 5. Nope. We can divide it by 6. And I could keep doing this all day long. Divided by 7. I could go up and up. I could go all the way to 41, and the only numbers I would find that would give me a whole number back would be 1 and 41. I could divide 41 by 1, or I could divide 41 by 41. That makes it prime. Let's look at another one. This one says list the prime numbers between 5 and 23. And this is going to take a little bit of work. I think the first thing I'll do is just list the numbers between 5 and 23. And now I think I'm going to start eliminating those that I know aren't prime. And the first thing I'm going to do is get rid of the even ones, because 2 is the only even number that's prime. The rest have 2 as a factor. So I'm going to get rid of all these even ones. There we go. Even one's gone. And then anything that's divisible by 5 is not going to be a factor, so I look for anything with a 5 at the end, get rid of that. So I've come to the end of my first bag of tricks. Let's start looking at them on a case-by-case basis. And 5 is where we start. And I think to myself, is there anything else I could multiply together besides 1 and 5 to get 5? And if I wasn't sure, I could try dividing 5 by other numbers. Divide it by 2, divide it by 3, divide it by 4. What I'd find is that only 1 and 5 are factors. So 5 is definitely a prime number. It's on our list. I would do the same thing with 7. And again, 7 would end up testing out as not being divisible by anything else. 9, well, I know 3 times 3 is 9, so I can get rid of that. 3 is a factor there. Now I've got 11. I would maybe run that through the same test. Only 1 times 11 is 11, so 11 is indeed prime. Then I've got 13. I might run through the same test, try it out on the calculator if I wasn't sure, but you'd find out that 13 was prime. Same for 17. Can try dividing it by 3, 4, 5, 6, 7, 9. You're not going to get any factors there. And then the same thing would happen for 19. 21, well, that 3 times 7 is 21, so I know that's not. Oops, I was about to add it there. Well, the 2 will work, because 23 is prime. There's nothing else I can multiply together to get 23. If you're not sure about that, try it out on the calculator. Try dividing it by some things. And that's our list of prime numbers, except I need to go back and read the problem more carefully. This said list the prime numbers between 5 and 23. So that doesn't include 5 or 23. So really my answer is this: 7, 11, 13, 17, and 19. Now, just to introduce you to the first few prime numbers so you kind of have them in your head, if I wanted to complete this list, I would add a 1 and a 2 and a 3 here. 1, 2, 3 all only have 1 and themselves as factors. So 1, 2, 3, 5, 7, 11, 13, 17, 19, 23. Those are the first chunk of prime numbers, and it's kind of good to get to know these, to remember that they're prime. Once you're familiar with them, they do tend to stick out a little bit, so I'm sure you'll remember them well. Let's look at one last type of problem with prime numbers. This says write 18 as a product of prime numbers, and product is when you multiply. So what they want is some numbers multiplied together that equal 18. So something's going to equal 18, something times something, or maybe something times something times something, and all those numbers are going to be prime. Another way that they call this is prime factorization. The way I would suggest doing that is break 18 down into some set of factors that you know. Not 1 and 18, that doesn't really get you anywhere, but let's see, 2 times 9 is also 18. And then 2, well 2 is on our list of primes, so I can stop with that one. With 9 I have to keep going, so what can I break 9 down into? Well, 9 is 3 times 3. 3 is also on our list of primes, so I've got 2, 3, and 3 as prime factors. If I multiply all of those together, I get 18. 2 times 3 times 3. 3 times 3 is 9, times 2 is 18. These are the prime factors of 18. This is writing 18 as a product of prime factors. So that's a little bit about prime numbers.